The quadratic formula. Okay, so you've done some completing the square. You should have done enough to realize that, wow, this method is, kind of cumbersome, right? Like, there must be a better way. And, so at some point somebody said, what if we try and solve? So, given ax squared plus bx plus c equals 0, solve by completing the square. So we're going to take the general quadratic, right? Ax squared plus bx plus c equals 0. We're going to solve it by completing the square. And what that's going to do is lead us to a formula, right? Because we know that a, b, and c are constants. Okay? And so let's see what we end up with when we try and do this. All right, so we are starting with, and when you're completing the square, we have to factor out the a, right? Like whatever's in front of the x squared. So that's going to become x squared. I got to divide the b by a, so this is going to be b over ax. We're going to leave some space. We got the plus c. We know we're going to be adding something in here, and we know that we are going to be subtracting a times that same thing, whatever we add, right? So that's just sort of a skeleton, and we're going to fill that in. Okay, next line. So we got a, x, plus. Okay, what do we do with the b over a? What do we do with the divide by 2, right? So what's b over a divided by 2? Okay, make life easier, right? If it's a fraction, don't divide by 2, multiply it by a half. What's b over a times a half? b over 2a, right? Just think b over a, 1 over 2, b times 1, 2 times a. Okay, so we've got plus b over 2a squared. Okay, so take half the middle term, right? Half of b over a is b over 2a. What do we do with the b over 2a? We square it. What's b over 2a quantity squared? Okay, and if you actually square it, you get?
B squared over 4a squared.
Yeah, b squared over 4a squared. Right? That's what we're going to add up. So what we have done now is written this as something which is squared, right? Okay. Plus c minus, all right, so we've got, we added that on, we got to subtract it off and multiply it by a on its way out, right? So b squared over 4a squared. Okay, so simplify this, and we're going to get plus c minus b squared over 4a, right? So multiplied by a. So plus c minus b squared over 4a equals 0. Equals 0. All right, with me so far? Now, a, b, and c are all constants, right? So if we knew a, b, and c, this is just a number. Okay, and we've seen that before, right? Where we've got, 101 over 4 or something, right? So we're going to move it over. All right, so a, x plus b over 2a quantity squared is equal to, so when I move it over, I'm going to change signs, right? So it's going to be b squared. Now, while we're at it, let's go with the common denominator, so we just have one term, okay? So let's go over here. So we know when we move it over, it's going to be b squared over 4a minus c. Okay, so this needs to be over 4a, so we're going to multiply top and bottom by 4a. So we're going to get b squared minus 4ac. So b squared minus 4ac all over 4a. Yep. Surely is it snowing outside? Yeah. Okay. Now what? Now we got to get rid of the a. How do we get rid of the a? We would divide by a, but that's kind of awkward because we're going to divide. So instead, we're going to multiply both sides by 1 over a, right? That'll get rid of this. Okay, so 1 over a. Okay, so we got x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Okay, you're not going to have to do this, but it's good to see where it came from, right? Okay, now what do we do? Got to square root both sides, right? So we've taken it to the point using the square root principle, right? Which is a very valid method of solving, right? And can actually make things a lot easier, right? If you're given vertex form, you're better off not expanding it and then trying to factor it. You are better off just using the whole square root principle thing, this idea. I wouldn't go so far as to, given something, let's complete the square on it, right? We did that. We understand this is kind of like, whoa, that's kind of awkward. All right, so you take the square root of both sides. Well, we move the frame around. Okay, so we got x plus b over 2a is equal to plus or minus, right? There's got to be two of them. The square root of b squared minus 4ac. And 4a squared has a square root, right? Which is what? 2a. 2a. Cool. Now we've got the same denominator, right? So we're going to move this over. It's got the same denominator, right? So it's going to become negative b, right? Plus or minus the square root of b squared minus 4ac all over 2a. And that's the quadratic formula. Okay. Now it'll be on your formula sheet. But if you sing it to the tune of Pop Goes the Weasel, you'll remember it. So I will inflict this upon you once and once only. I know, I don't sing. So. Okay, so you just go x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Got that? So just remember it to the tune of Pop Goes the Weasel. You're going to be using it a lot. Okay? It's on your formula sheet. So you shouldn't mess it up. Okay? And yet you might. So there's a couple things to remember about this. Whatever b is, we're going to be changing its sign here, right? So if b is positive, it's going to become negative. If it's negative, it's going to become positive. When I square something, what do I always get? I always get a positive. So this term here, no matter what the b value is, will always yield a positive number. Okay? Some of you will insist that it be negative because you enjoy getting things wrong, I suppose. I don't know. So you just got to remember that this thing here, when you're squaring the b value, you got to put it in brackets, right? Because there's a difference between this and this, right? What's this equal to? What's this equal to? Right. Okay. So this is what we're doing. We're squaring some value of b. We are not doing that. Okay. We are not taking the negative of b squared. We are taking the b value, whatever it is, positive or negative, and squaring it. If you're doing it on your calculator, save time. Don't bother putting the negative in. You know the result has to be positive. So if b is negative 5, just say 25. If b is negative 11.2 on your calculator, just go 11.2 squared. Don't bother with the negative because this is what you'll type in. And it'll be wrong, and then you'll write it down as a negative because you'll forget that this is always positive. You know, things will go badly for you. All right, so let's go back and let's do a couple of ones we did by completing the square, or one. Yeah. Let's do at least one, maybe two. So we had this solving quadratics by completing the square, right? So let's pull out the one, I don't know, what was the worst one? How about 2x squared minus 9x minus 13, right? That one would be ugly because you get fractions in there, right? Okay, so 2x squared minus 9x minus 13 is equal to 0, right? So we did that one, it'd be 2 bracket x squared minus 9 halves. and then you take half of that and get 9/4, and then you square that and get 81/6, right? So not nice numbers, right? All right, so here's what we're going to do. First thing we're going to do is we're going to look at this and we're going to say, okay, what's A, what's B, what's C? What's A? 2. What's B? What's C? All right, so we've identified A, B, and C. Now we sit down, we look at our formula sheet, and my advice to you always, for any of this, is write out the formula you're going to use. Okay, just write it out. If you write out the quadratic formula, humming, pop goes the weasel while you do so, you know, like 20 times, you're going to know it. Still, look at the formula sheet when you do it so you don't mess up. Okay, so just write out the formula. Okay, so we've already said what A, B, and C are. We're just going to substitute them into the formula. So I've got negative 9. I'm just going to write that as positive 9. I'm not going to write down negative 9, right? That's too much. Just 9. I will put the negative 9. So it's negative 9 quantity squared. Always put the B in brackets. Whether it's positive or negative, just always put the brackets down. At the very least, it should remind you that, hey, this has got to be positive. Minus 4 times A, which is 2, times C, which is negative 13, all over 2 times 2. Okay, so we're looking at the formula, we look down at the next line, and we can see what's what, right? There's no surprises there, I didn't work anything out. If you look at it, you say, negative B should be 9, plus or minus squared. Okay, so B is negative 9, because that's what's being squared, minus 4 times A is 2, C is negative 13, all over 2A, right? Okay, so now we just... Okay, so I got 9 plus or minus square root. All right, so what do we got here? 81 minus a negative, right? Minus a negative gives me what? Plus. Okay, 4 times 2 is 8. 8 times 13 is what? 104. 80 and 24. 104. 104 over 4. Okay. 9. Root, add those together, what do we get? 185. Okay, so at this point, you try and say, all right, are there any perfect squares that go into 185? If there were, it would be 25, but it doesn't, so, you know. It's got to end in a 5. The only thing that ends in a 5 is 5, 25. That's it. All right, so do you have your notes in front of you? Look back at number 2. What does the solution look like? Which one was this? It's completing the square. Solving by factoring. There we go. Completing the square, and it's 2c. We got 9. Okay. Why did you write 200? Oh, that's a 1. Is that 1? That's 1. Okay, that's 32. All right. So, you look back. I'll compare with known ones. If I'm not sure if you're writing, I always sort of look and say, all right, I know this is a 1, and you got this right. So, yeah, okay, that's his 1. Okay, you look back, what did you see? This, right? 9 plus or minus the root of 185 over 4. This is what we mean by an exact value, right? I ever ask you for an exact value? That's it. Done, right? You simplify this if you can, right? You're not a simplifier, a radical. And that's it. Done. 2 solutions, right? 9 plus root 185 over 4. 9 minus root 185 over 4. You don't have to list them separately. They're there. If there's a context to this such that it's a width or something, you know, we know the root of 185 is bigger than 9, right? Because 9 squared is 81. So, okay, you know, we're not going to worry about that. If this was a width, that'd be a minus. We'd end up with a negative. We would reject that. Okay. This is not. It was just a, hey, here's the thing, right? There's the thing. Should we do one other one? What else did we have? Yeah, let's do the 3x squared minus 24x plus 4. Was it 3x squared? Okay. Now, I mean, looking at the timeline, we got like 2 days for this, right? I don't know why, but we got like 2 days for this.
We need to learn how to.
Yeah, I guess. I don't know. So I might switch things around. I'm not going to be here on Wednesday. I do have a guy that's a math sub, but here's what we'll do, I think. Tomorrow we'll do discriminant, and then Wednesday will just become a work period on the whole thing. And you can ask him. The guy's like, he's a retired math teacher, so he's taught for a million years. But this way he won't have to worry about teaching and recording and stuff. Okay, so we're gonna do that. We're gonna flip Tuesday, Wednesday. So tomorrow we'll do the discriminant. It's actually staring you in the face. You just don't know it yet. It's there on the board. Well, it's not there on the board yet, but.
Well, it's not time.
But it's in the quadratic formula. It's just a part of it. Okay, what's A? What's B? What's C? X is equal to Did anybody ask your parents if they knew the quadratic formula?
No.
Oh, you go home and ask them. They won't have learned it to the tune of pop goes, but just see how many remember it, right? It's just something that you use a lot. Like, it's on the formula sheet for 30-1 and 30-2. You're probably not going to use it in those courses, but it's there, right? I mean, they're saying, hey, this, it's that important that, we're going to give you this formula. Okay. So what's negative B? 24, right? Everybody good with that? We're not going to write down the negative of negative 24. It's just bad. It's like, really, come on, show some skills. We are going to bracket this, right, to remind ourselves that that will be positive. Okay, minus 4 times A, which is 3. Now, I always make A positive regardless, right? I mean, if this started as negative 3x squared plus 24x minus 4 equals 0, I would go through and just change all the signs. Okay, so. And there's actually a reason for that, because when you look at the formula, well, we'll look at it tomorrow. So tomorrow we'll look at the reason. Why is it better to have the A as positive, right? Because tomorrow we'll look at the discriminant, which is actually sitting on the board somewhere right now. All right, let's make life easier. All right, so x is 24 plus or minus square root. All right, 24 squared is what? 526? 570. I should know this, right? I think it's like 496 or something. 4 times 3 times 4? 48. Over 6. All right, so x is equal to 24 plus or minus 48, 58, 68, 78, that's like 30, but we need 2 fewer than that, or 2 more than that, so what is that, 532? 528, we need 2 less than that, something like that. 528. All right, 528, so that probably reduces, right? So you're looking for the largest square that goes into 528. So divide 528 by 4, what do you get? How much? 132. 132. Okay, that's divisible by 4. So how many times does 4 go into 132? How many? 132 divided by 4 is? 33. Okay, so we can pull a 16 out, right? There's 2 4s. Okay, so what's 528 divided by 16, right? It's going to be 33, right? But just make sure you get that. All right, so x is equal to 24 plus or minus 4 root, what did we say it was, 33? Yeah. Okay, everybody know how we got the 4 root 33? Okay, so largest perfect square that went into 528 was 16. 528 divided by 16, so we can write it as 16 times 33, which is root 16 root 33, which is 4 root 33, right? And if you need to show more steps, by all means, show more steps. Over 6. Okay, so what goes into 24, 4, and 6? 2. Okay, so we can divide this, and this by 2. Okay, so really what it's doing is you're taking a common factor of 2 out of the top, right, and then you're dividing it into the 6. Okay? I'm not going to write it that way. I'm just going to divide everything by 2. So it's 12 plus or minus 2 root 33 over 3. Okay, now you look back at your page, and what do we have? So we got 4 plus or minus 2 root, yeah, something different. 4, well, okay, but if it's over 3, root 3. Oh, yeah, so we'd have to multiply it through the answer we had. I think we had a root 3 on the bottom, or did we change that? We had a root 3 on the bottom? Okay. So what was the answer that we had?
4 plus or minus 2 root 11 over root 3.
This? Okay, so, right? Now, you're not going to get this on a test, right? You're going to get this. You're going to look at this, you go, oh, it's wrong. What am I going to do? The world has come to an end. You can do a couple of things. One is you can actually just work out the positive one of these. Just go 4 plus this, get a decimal, and then try each of your 4 answers and see which one comes out the same. All right, so here's what we're going to do with this. We need a common denominator, so this will be 4 root 3 plus or minus 2 root 11 over root 3. Right? So all I'm doing is just multiply top and bottom by root 3 combined. Right? Are we good with that? Can't have root 3 on the bottom, so we're going to multiply by root 3 over root 3. Okay, now we got to do this by distributive law. So what's 4 times root 3, which is 4 times 3, which is 12. Plus or minus 2, root 11 times root 3 is root 33, and a 3 on the bottom. Aha. Okay? All right. Now, what was easier to do, right? I mean, I think this was easier to do than the whole completing the square thing, right? So, we shouldn't, I'm not actually making up the test, but we shouldn't ask you to solve by completing the square, okay? If we do, I will tell you, we're going to ask you to solve one of these by completing the square, okay? And you'll just know, okay, I got to solve that square. Otherwise, really, you shouldn't have to. When you're solving quadratics, the first, okay, so today it's all about the quadratic equation, right? It's all about this. So you're pretty much just going to be solving using this. Right, and then tomorrow we'll do the discriminant, and then Wednesday will just be a work period on everything. Right, then what? I think we got a quiz on Thursday or something? Yeah. Okay, we got a quiz on Thursday, and then we got a test next Tuesday. Right, time flies. After spring forward and fall back. After losing an hour of sleep on the weekend, right?
God, no.
It's Sunday at 2 a.m. It becomes 3 a.m. Right, we spring forward, so it'll be lighter in the evenings then. Unless you're in Saskatchewan and they just leave it.
Saskatchewan just doesn't care.
Yeah, there's a few. I think Arizona doesn't. There's a few places that don't change, right? And so Saskatchewan. So right now we in Saskatchewan are on the same time, right? Because we're both on standard time. And then we'll switch to daylight, and they'll just stay on standard time. Right. Okay. So any questions about solving by the quadratic formula? All right. So what I would do is that. Write this down. Like when you're doing the questions out of the book, write down the question that's in the book. Okay. If you have to do any manipulation to get it into this form, then do that. Identify your A, B, and C. Write this down while humming to yourself, either silently or just quietly humming. You can find it. You go on YouTube. You can find quadratic formula to the tune. I'm sure they're much better singers. Maybe we could get the music, right? They could just accompany us. Or the choir. We get the choir to do it. I should do that. I'll talk to Think Funny. We want the choir and the band. Right? The whole thing. We'll get the Philharmonic or something. Right? Yeah, it's got to be. Substitute in this is if you're going to square this in your calculator, which likely you're going to square 24 in your calculator. Don't do negative 24 squared. Just do 24 squared, right? Understanding that, yeah, we're just going to get a positive, okay? If you want to do negative 24 squared, bracket negative 24 bracket squared. Okay? Make sure that's positive. Collect, reduce. 1 step, 2 step, doesn't matter how many steps you take to reduce, right? Just get it into the reduced form. And then simplify. Okay, and you'll end up here, right? You won't end up with this, which then becomes that. After some work, you just end up there. Yeah, is there anything else? I mean, yeah, we could do the soccer one, with the negative 0.06 and all of that, right? But it's just the same deal, right? It's just putting the numbers in. When you're doing the soccer one, though, right, since you're going to have decimals in here, we are likely just going to work it out rounded to the nearest hundredth, whereas this is an exact value. If we said rounded to the nearest hundredth, then you're going to go 12 plus 2 root 33 divided by 3. Just make sure you put brackets, right? If you want to work this out, you're going to have to bracket that. 12 plus 2 root 33 in brackets divided by 3, enter. Otherwise you'll get it wrong. And then second function, enter, bring it back down, change the plus to a minus, hit enter again, and you'll have your 2 answers. Make sure they make sense, right? Because if you enter this, 12, so you put this in your calculator, 12 plus 2 root 33 divided by 3, what are you going to get? Right? It's going to do this first, right? And then it's going to add 12. So if you look at this, you say, okay, what's root 33? It's between 5 and 6, but it's closer to 6. Let's call it 6. So this is 12. 12 plus 12 is 24 divided by 3 is 8. I should get about 8. Okay? What will you get if you enter it this way? Well, this is 12 divided by 3, which is 4, plus 12 is 16. Right? So the question is, do I get a number that's around 8, or do I get a number that's around 16? And then what's the right number, right? It's around 12. So. All right, done. Now.